Okay, today we're going to talk about squares of binomial. And anybody want to guess what, before I show you, what's the squares of binomial? Anybody want to guess what that might be? Squares of binomial. What would that look like? Yeah. Yeah, a plus b, something square. Is that the only way you could do it?
No.
What else could you have? Yeah.
B plus A.
I'm sorry?
B plus A.
B plus, okay, I guess you could have b plus a, but that's the same thing as a plus b. I mean, a could be anything, b could be anything. Yeah. You could also have minus, right? So these are squares of binomials. That's what we're going to study today. Is that okay? So you'll see why they're called. By the way, what do you think we call them squares of binomials? That's what we have. That's what we have, right? We have squares of binomials. Isn't that what we have? So all the squares of binomials will look like this, right? Of course, a could be anything you want, right? A could be x, b could be y. Are they going to be that simple every time?
No.
A could be some polynomial, right? It could be some binomial, like as you've seen before. You see what I mean? Anyway, we'll deal with that later. But first, let's start with, I'm going to ask you to factor this. And you may say, wait a minute. That's really simple. That's not even the ones that we talked about last time, because this is a lot simpler than we talked last time, because look at the coefficient of the first term. It is 1. Do you know how to all factor this? Yeah. Okay, go ahead, everybody. It's sort of a warm-up. Oh, wait. This should be easy. So how many ways are there to get that first term? Of course, we have to multiply 2 what? To get trinomial. You have to multiply, yeah. 2 binomials to get trinomial. Is that right? That's the only way that we know. So we're going to, how do we get x squared for the first term? Only way is what? X and x. How many ways are there to get multiply two numbers so you get 49? 1 and 49, that's the easy one. What else? 7 and 7, but they both have to be negative, because look, your middle term is negative, right? If they're both positive, is there any way for the middle term to be negative? No. Okay, so by now you should sort of realize, okay, you know, I'm going to need both of them to be negative, right? So anybody have the answer? X plus what and x plus what? How about, yeah, Lindsay?
It's x plus negative 7 times x plus negative.
That's what I got. Right. Did you all get that? All right, so how do we write the answer? Yeah.
I wrote as x minus 7 and parentheses to the second column.
Yeah, that's what I did too. Because, I mean, you could write it twice. I even checked it. Yeah, you could write it twice, or what's a better way to write this? As x, yeah. X minus 7 squared. Isn't that better? Okay, so let's move it up a little bit. So there you go, okay? Did you all write it this way? Isn't this better to write it this way? By the way, what did we just say this is called? Something binomial squared. What do we call this? Squares of binomial. Okay, this binomial is called squares of binomial. Is that okay? By the way, when you square a number, not just a binomial, like, what do you get if you square 2? 4. What do you get if you square 3? 9. What do you get if you square 4?
16.
What do you get if you square 5?
25.
What do you get if you square 10? 100, right? What are these numbers called? 4, 9, 16, 25, 100. They're called? Camilla? Square roots? Oh, that's going backwards. Square root of 10 to square root of 100 will give you 10. Square root of 4 will give you 2. But what do we call these numbers? Like 4, 25, 49, 100. These are called the squares, right? Perfect squares, not any square. Perfect squares. You guys remember those? So if that's right, no, you don't remember the numbers like. Let me hold on. Let me try to hide this thing. So here, numbers like these, right? 4. Isn't that 2 squared? 9. Isn't that 3 squared? 100. Isn't that 10 squared? These are called perfect squares. You guys remember that? Yeah? So look, x minus 7 squared, right? That's a square of binomial, right? Squares of binomial. What do you think that then this trinomial is going to be called? Any wild guess? Because how do we get this trinomial? If you do x minus 7 times x minus 7, right? So look, if I do 2 square, I get 4. That's called perfect square. 3 square, I get 9. 9, right? That's called perfect square. Anybody have any guess as to what this trinomial might be called? Yeah, Chuck?
I have a question.
Yeah.
Are there imperfect squares?
No.
Okay.
So anyone guess? Yeah.
Perfect square trinomial.
That's right. It's called perfect square trinomial. I call it in short PST. Is that okay? Do you see why it's called perfect square trinomial? Why don't we just call it perfect square? Why do we have to say perfect square trinomial? Yeah, Chuck?
These perfect squares are the numbers.
Yeah, the perfect square refers to these numbers, like 4, 9, 10, 49, right? But since these are trinomial, right? They're called perfect square trinomial. Is that okay? So you will hear me referring to these trinomial as perfect square trinomial. By the way, is any trinomial perfect square trinomial? No. When do you get perfect square trinomial? When you multiply when you have squares of binomial, right? This is one square of binomial, right? When you have a square of binomial, right? Then you get this perfect square trinomial. Any question? Are we good? Okay, so let's move on to example 2 then. So take a look at this example 2. I have 4p squared minus 20pq plus 25q squared. As a matter of fact, it turns out this section, I don't even have to teach you how to do these, because haven't we learned how to factor, right, trinomials that look something like this? Isn't this what we did last time? Which form do we have here? A x squared plus bx plus c. Do you see? Isn't this what we did last time? Right now, a is not what? 1 anymore, right? So what's a right now? No, a is not 4. A is not p. A is 4. Remember, ax squared plus bx plus c? So right now, my leading coefficient is not 1 anymore. But do we know how to do this? Isn't this what we did last time? How many ways are there to get 4p squared? There are 4 ways? 2. What are the 2 ways? Yes.
4 and 1 and 2 and 2.
Yeah. You mean 4p and 1p? And 2p and 2p, right? What about negative 4p and negative 1p and negative 2p and negative 2p? Do we have to worry about those? No. We're going to deal with the negatives with the last term. Does that make sense? So there are really 2 ways. Which one, remember I gave you a big hint? Which one are you going to start with first? 4p plus 1p or 2p plus 2p? Class? 2p plus 2p. They like the one that are close to each other, remember? Not the one that are sort of far away, far from each other. Go ahead, everybody try. See what you get. Alright, Eric, what did you guys come up with when you try to factor?
Is there an answer?
Yeah, you can tell me the answer.
2p minus 5q squared.
That's right.
Yeah.
Because you get 2p minus 5q.
Also, it's squared.
Right. Didn't you? I thought I see. So don't you get 2p plus negative 5q and then 2p plus negative 5q? Right? So the answer is what, class? Yeah. You see how easy this is? And of course there are 2 ways for negative 25. How come I only put negative 1, negative 25, negative 5, negative 5? How come I didn't bother to even write the positive ones? So? Yeah, the middle term is negative, right? And then the last term is positive. If they're all positive, do I have any chance to make the middle term to be negative? No. Okay, so see, as you do this more, you will see that it sort of gets a little bit easier, because you can kind of get rid of some of the possibilities, right? Possible pairs. You know that you don't need both to be. You know that you don't want both of them to be positive. So there it is. By the way, look. Again, look at this trinomial. What kind of trinomial is this? Now that we factored it, it's a perfect square trinomial, isn't it? So guess what? For homework tonight, it's going to be really easy, isn't it? Because many of them, I think almost all of them will be, if it factors, perfect square trinomial. So we're doing special case.
Do I have to write that?
No, you don't have to write it, but I want you to recognize that it is. Because, you got squares of binomials, right? You got a square of binomials, so, you have perfect square trinomial. Easy enough? Yeah.
On our homework, will all the answers turn out as squares of?
Yeah, so this section they're talking about. But let me show you example 3. Let me show you example 3. This one here, I have 100 x to the 4th power minus 120 x squared y plus 36 y squared. Okay. Do you think this is going to be a perfect square trinomial?
Yeah.
Yeah, but I think it will be, but how do you know? Well, we're not so sure. We could try. But should we look at 100? How many ways are there to multiply 2 numbers and get 100? There are many. So, but before you do this, if you remember what I talked about, before you factor, you should always look for your Closest number, yeah. But before you factor even, not even thinking about like factoring, what should you do? Yeah. GCF. What's your GCF? Do you have any GCF for this trinomial? What's your GCF for this trinomial? Sammy, do you see a GCF? No? 4, exactly. So if you see that the GCF is 4, write it this way first, right? Then look at the trinomial. Isn't that easier to factor? Right? You now have 25 instead of 100. Because 100, there's so many. And then you try to factor the trinomial inside. Isn't that easier? So do you see why I'm telling you to factor out your GCF before you factor, right?
Yeah.
It just makes it so much easier. If you didn't see that, I mean, it still works, but you know, there are a lot more possibilities that you gotta try, possible ways for this to factor that you gotta check. You know what I mean? Now it narrows it down more, right? Because how many ways are there to multiply two numbers and get 25?
A lot.
Two numbers?
No. I thought you meant like 100.
Yeah, not 100, but 25 is a lot less, right?
Yeah.
25 and 25x. By the way, what do you need so that it becomes 25x to the fourth? 5 times, no, 5x to the second times 5x to the second, that's 1. What about 25x to the second times x to the second? That works too, doesn't it? Which one are you going to try first? The one in the middle, right? 5x squared times 5x squared first, right guys? And then you got 9. And then you have y at the end. Go ahead, everybody try. Everybody try, see what you get. Okay, here we go. How many people, by the way, what do I do with this 4? When I try to factor this trinomial, does it go away? No, it's still there. It's a factor, right? Greatest common factor, so it's still there. How many people got this? 5x squared plus negative 3y. 5x squared plus negative 3y, right? Because for 9, right, there are two ways for this to be true. 1, 9 or negative, negative 1. By the way, they both have to be negative, right? Because if they're both positive, there's no way it's going to be negative in the middle term, right? Anyway, so when I do this, what's the answer? 4 times. Here, I check this. Can I forget about this 4? No, you still need it there, right? Otherwise, you don't get what we had before, right? So here, 4 times 5x squared minus 3y in parentheses squared. Does that make sense? Okay, somebody said, should I multiply 4 to the binomial? Should I do that? No, if you do, then you get this back, right? We're trying to factor here, not multiply this thing out. So you simplify. We're not trying to simplify. We're doing opposite of simplifying, isn't that right? We're factoring out, kind of. Okay, any question? Do you see what we get here? Okay, so let's then move on to next one. Let's change the gear a little bit, and I'm going to show you some shortcuts for squares of binomial. Is that okay? Because this is going to be very helpful when you do your homework tonight. They're going to ask you to do something like this. They're going to give you something like this, you know, squares of binomial, and they're going to ask you to multiply it out. And of course, we all know how to multiply this, don't we? How do you multiply a plus b, the whole thing squared? What's it mean? Dana? Yeah, it just means a plus b times a plus b. That's why it's called squares of binomial. And I wrote it back. I wrote it vertically. I like I like to multiply this vertically because, of course, when you multiply vertically, you get the first and the last term. And how do you get your middle term? You do the diagonals, right? You guys remember?
Yeah.
So what do we get? A times a? A squared. What's a times b? Plus ab, right? Plus what? What's b times a? ab again, and you get, of course, b times b, you get b squared. Do we have any like terms? Yeah. How many of these ab's do we get? 2. Isn't that nice? We always get 2. Because do you see why we get 2 of the same ones? Why? Why do we get 2 of the same middle terms? Yeah? Yeah, you're multiplying this exact same binomials together. Isn't that right? Do you see what I mean here?
Yeah.
Do you see where that 2ab comes from? Sometimes people think it's a squared plus b squared. Is that what you get? No. Okay, please don't think that. Like, you don't distribute this exponent, do you? When do you do that? When if it was inside, if it was what? If you had a instead of a plus b, if you had what? How would you get a squared and b squared? If you had a times b inside. In other words, if you had a monomial here, right? If you had, does that make sense? If you had monomial, then you get a squared, b squared. But this is a plus b. This is a binomial, isn't it? Okay. Do you guys see what I'm trying to say? Yes? And again, an AB, isn't that the first term times the second term? So you get the 2 of the first term times the second term. Isn't that nice? Do you see why we get 2 of those? Okay, what would happen if I have this? Go ahead, everybody multiply it out and see if you get similar result. Go ahead, everybody try. So you're going to have a plus b, a plus negative b times a plus negative b, right? Go ahead, multiply it out. See if you see what you get. All right, it shouldn't take too long. So when you do it vertically, what's a times a, guys?
A squared.
A squared. Look, what do you get when you do a? A squared plus, now a plus negative b, what do you get? Negative ab, don't you? Plus, what's negative b times a? Negative ab again. And of course, what's negative b times negative b? Positive b squared. Isn't that what you get? Okay. So, look, don't I get a squared minus 2ab plus b squared? Again, look, this time you have 2 of the same. Just like before, you have 2 of the same middle term now, but they're both negative, isn't that right? Why are they both negative? Yeah? Yeah, how did they become negative? Because, yeah. Yeah, because she had negative b here. It was because it was a minus b. Does that make sense? Right? So, do you see how we get 2 of these same middle terms? Right? And how do you get the middle terms? You multiply the first term and the second term, right? You multiply them together and you get 2 of those every time. Do you see the pattern? So what can you say? So here's the, by the way, and these are called PST, right? Perfect square trinomials. So here's a fact. If I have a plus b whole thing squared, what's the shortcut? This is always going to look like? What's the shortcut, guys? It'll always be a squared. Thank you, Spencer. A squared plus 2ab plus b squared. What if I have subtraction sign in the middle instead of addition sign? Let me put that as red. What would that be, Samuel? Minus now 2ab plus b squared. Is that? Do you see the shortcut? Here's the shortcut, right? It's a fact, isn't this right? Nice shortcut to remember. But do you see why this works? Okay. Any question? So please note, this is not, many of you messed this up. Is this equal to this? No, please, this is wrong. Okay. Or this. Some of you did this on your test, remember? Does this mean this? Right? They're both wrong, right? Please don't do that, right? Yes, understand? Hello? You just saw when you multiply these 2 binomials, what do you get, guys? Trinomials, right? Except, of course, if it was a plus b times a minus b. That's the only exception. But all the other time, you always get a trinomial, don't you? Okay, please remember, right? Okay. Any question? So knowing this, we're going to do some examples, because on your homework tonight, they're going to ask you to do something with this shortcut. Okay, is that okay? So let's move on to next example. Let's take a look at example 4. It says write each square as trinomial. And of course, x plus 3 squared. That's a square of a binomial, isn't that right? Squares of a binomial. So, what do I get when I multiply x plus 3, the whole thing squared? Well, you know, we could actually multiply this out, can't we? We all know how to do that. That's easy. But could we use that shortcut that we just learned? Right? So it's going to be, wouldn't this be something squared plus 2 times something something plus something squared? What is your a in this case? X. What is your b in this case? 3, right? So couldn't we just plug in a, b, like look, my a is x, so doesn't that become x squared plus 2 times? My a was, right? Remember this was ab, so x times 3 plus 3 squared. Isn't that a lot easier than actually writing them out and multiplying it out? So what's the answer, guys? X squared plus 6x plus 9. Easy. You see how that shortcut is really nice, right? Otherwise, you have to actually multiply the whole thing out, right? So using the shortcut again, try this one yourself. And of course, it's going to fit in that. Now, do you see why it's negative this time? Negative 2 in the middle term? Do you see why it's negative here, guys? Yeah, because why? 7x minus 3, right? Instead of here it was plus. What is your a in this case? What is your b? No, your b is not negative 3. Yeah, b is 3, just 3, right? Because I already have that negative. If you were to change this into an addition, right, then you could say the b is negative 3. Does that make sense? But let's just do it this way. Go ahead, everybody try. See what you get. Okay, so who could tell me what goes into the first parentheses? That's my a, right? So, Libby?
49x squared.
Oh, don't multiply them yet. What goes into the first parentheses? What's your a? Yeah, 7x. And then here, what goes in here? Second parentheses.
Or no.
So it's a squared minus 2ab plus b squared, remember? So, you,
Negative 3 times 7.
if you wanted to change it to addition,
Oh.
that's fine, but we're going to keep it as subtraction. That's why I kept it as negative 2 times something.
3 times 7.
Right, so it wouldn't be this, right? 7x squared minus 2 times 7x times 3, right? That's your b, plus b squared, which is 3. Again, if you wanted to change it to an addition, that's fine, but if you did, would this be negative 2 here or plus 2? Plus 2 if you change it to an addition, right? But we kept it as a subtraction. You okay with that? Okay, what's the answer? What's 7x squared, by the way? Is this 7x squared? No. Is it 14x squared? No. What's 7 times 7, guys? Please be careful. Many times people will write down 14 or leave it as 7, something like that. It means 7x times 7x, right? You should have gotten 49x squared minus 42x plus 9. Does that make sense? Yes?
Yes.
And you get what I'm trying to say? Okay. All right, try this one now. 4x minus 5y squared. Again, wouldn't it fit this pattern? Something x squared minus something something plus something squared. What is your a in C here? 4x. What's your b? 5y. It's not negative 5y unless you wanted to change it everything to addition. Then it would be negative 5y. If you did that, would this be negative 2? No, right? Do you want me to do it that way? Okay, go ahead, everybody try. Okay, how many of you got 16x squared minus 40xy plus 25y squared? Raise your hand. Is this easy? Isn't this nice? You don't have to like really multiply the whole thing out. Now we're just using the shortcut. Didn't we do that before with the difference of squares, right? We knew that the shortcut for a plus b times a minus b was what? A squared minus b squared. You guys remember that shortcut? The same idea. Here, try this one. What is your a in this case, guys? Is it 3? Your a is what? This one is sort of interesting. Is it 3x? It is 3x squared. The whole thing is your a, right? What is your b? Is it negative 2y squared or 2y squared? 2y squared, because I kept this, I kept the middle one as negative. If I were to put plus 2 times something, then you could actually, right, do it as negative 2y squared if you wanted to, but it's the same thing. I'll show you that in a minute. Go ahead, everybody try this, okay? So, who can tell me what goes into the first parentheses? Matthew? No, don't, before you multiply them out. What goes into the parentheses? Show me the work. What will go into the first parentheses? Yeah, 3x squared. What about the second one? No, it's the same thing. Remember, it's a squared minus 2ab. Again, another a. What's your a again? 3x squared. So you get 3x squared here, 3x squared here. What goes in here? 2y squared here. Does that make sense, guys? Right? Do you understand? Did you all get this? 9x to the fourth minus 12x squared y squared plus 4y to the fourth?
Yeah.
Does that make sense?
Yeah.
Any questions?
No.
Easy enough?
Yes.
Okay. Now let me show you this, because some of you are still getting confused. Look, if I had, give me a sec here. If I had a plus b squared, guys, what do I get? A squared, what? Plus 2ab plus b squared, right? What if I had a minus b squared? Could I rewrite this as a plus negative b squared?
Yes.
If I did it this way, then what would you get? A squared, what? Plus, again, 2 times something, something, plus something squared. What goes in here? A. What goes in here? Now it's negative b. Now, if you wanted to change everything to addition and think of it this way, that's fine. Okay, you could always do this way, but, right? But isn't that another shortcut?
Yeah.
A squared minus now what? Because positive times negative, isn't that minus? Plus negative 2ab plus, what's, whoa, we're not done. Guys, what's b squared? Negative b squared.
Positive b squared.
Do you see why it becomes this? A squared minus 2ab plus b squared. So if you want to keep everything to addition, it's fine as long as you, but this pattern will always work then. If you keep everything as addition. Do you understand? But if you don't, right, the middle term is negative. Any question? Can you do something like this for your homework tonight? Yes. Good.